It's a 3-story house. I'm a big fella. Going up and down 3 stories, it's going to be a nice exercise for me.
Oh, hell no, man.
Part of the testing is also very important to check the bonding. We're not worried about the spiders. Sometimes one problem could relate into 3 or 4 failed regulations on the EICR. We are in Southmead. And this is quite interesting because a lot of people asking me how long does it take a 3-4 bedroom EICR to be completed, and I usually say 3-4 to 5-6 hours, but this depends on how much of personal furniture we need to move. This needs to be recognized because the client moved everything out of the wall, all the furniture, all the wardrobes, allowing me to quickly identify all the sockets, go around the house. It's a 3-story house, so I'm a big fella. Going up and down 3 stories, it's going to be a nice exercise for me.
Oh, hell no, man. What the?
Here is the board installed by a massive contractor in England. It's all brown and blue, so it looks like quite recent installation. Let's see if we find something, maybe some feedback, some shocks from extractor hood, but I'm going to find out if this was just a static one-off or if there's a fault with it. But now let me show you what my client has done for me. Moving all the little side cabinet for allowing me to get to that socket, like this, the bed, the desk. And that's not everything. So here, moving the bed off, access to these sockets. So I can imagine the desk goes up against the wall. Even moving the wardrobes away, getting access to that socket. These are usually the sockets we'll never get around to do, because if we hassle with your furniture and then breaks apart, we don't want to take responsibility for it. So again, moving the side cabinets off the walls, just pretty good. Last room, well, that's quite easy. Access to these 2 sockets. So if you, as a client, would like to help us electrician to do our job really efficiently, just help us to do like this client did on that house. So well done. This is the extractor hood. We'll find out if this is only a static charge that it was there or if there is a problem with it. It looks like, on the first glance, the cables are originally as they have been put into a fuse board. That's how they still are in here. I don't think anyone had any influence on this installation since it was new, so it should be absolutely fine, but stay tuned to see if I find anything here. So you remember on the many videos I showed you about these bus bars and the MCBs that have the basket. So I'm going to be unscrewing this circuit breaker, and the basket here behind is going to move backwards. So as I'm unscrewing, you can see how this basket just moves back, and now there is a flex on it. So if you or anyone else would have put this with the screw already tightened all the way, it would never had an opportunity to clamp on that bus bar. So please always verify from the bottom if all of these baskets, like you see on the back of it, there is actually that silver basket that's holding onto that bus bar, and there's no flex. Well, there is now because I've created, but if I clamp on it, yeah, we don't have that flexibility. So that's quite important. Always check this.
Nice.
The EICR, the first thing I do before I actually do anything, I've got this tiny little device. I go around, push them into every little socket. If I go in, start taking this fuse board apart, then I'm going to find out a problem. I have no evidence that it wasn't me who caused it in the first place.
What have I done?
So going around the house using such a little socket device, these are maybe 20-50 pounds from Screwfix. It's giving me a feel for the installation. Like this one, together with the board, it looks like no one's touched this. I'm getting the socket tester in every socket. It feels really, really good. So I'm pretty good one about that one. But the next thing what I do is I actually functional testing the RCDs, like 1 and 2. Fine, works at the first time. Sometimes they don't. If they are really old, they call them like a sticky RCDs and they don't trip. So that's a different problem which you have to be aware of. Now it's the time. I'm going to take this ZS test. So slightly from the reverse. Some people would do this last. Sometimes I do it twice. We want to confirm that there is a ZS. So on this occasion, we're going to do it as a last thing. So making sure we leave the installation back as it was and we've got a nice confirmation everything is sound. For now, we're going to actually kill the power. RCDs, main switch, each circuit breaker, and put the information on a spreadsheet and start cracking on with the testing. If you've done your electrical training, you will know what I need to do now. So super crucial, everything needs to be off, the whole installation needs to be off, and at this point we are removing the main earth. The reason why this is so important to do it that way and do it in sequence, removing the main earth, we need to make sure that we put it back again before we do anything else. Set my tester into Z. So clamping on the earth, live is here, neutral's there. Press to test, 230, live to neutral, live to earth, and earth to neutral 0. So it looks good. 0.20, that's really nice, and prospective electrical fault current is 1.16 kiloamp, so it's all looking good. A maximum resistance on TNCS earthing, it's 0.35, and this one's 0.20. That's pretty good. Before we do anything else, that cable needs to go back in and we can resume the rest. If you were taught really well, you're gonna put the earthing back in and then you're gonna record the value. If you got a meter like mine, it remembers your tests, so 1.16 Ka. Well, actually, it tells you what you have to do as well. 1.16 Ka. Off we go to the next one. Means of earthing, distributor facilities. We don't have the electrode. Main switch RCD. Location WC. As a part of the testing, it's also very important to check the bonding. So this is the bonding for the gas. We're not worried about the spiders. Well, are we? Checking if it's properly sits really nicely. It does. There's no wobble in it. I'm happy with that. Okay, let's just put this back. That's okay. Happy with that. We can say that we've checked the installation to the gas pipe. Yes. Oil, not applicable. Lighting protection, not applicable. And no structural steel. Well, this is where I have to go around everything, check all of about, I don't know, 70 questions. A lot, so let me go through that really quickly. Service cabinet key. Let's open this up. The first question, service cable. So this is that cable. I'm looking for quality of that cable. Has it been damaged? Sometimes this is filled with tar, and if tar is leaking, so I'm just checking for that. Service head, nice and clean, recent. Earthing arrangements. I can see this coming from the supplier. It's properly fitted. There is no loose connections. Pass. Meter tails. This is your meter, and these are the meter tails. Yeah, securely fitted. Good. Pass. Metering equipment. I don't see any issue. Security of fixings. Done. Isolation. There is no isolation. Not applicable. Is the personal remote holder been notified? Yes, they have been. Consumer isolator were present. There is no consumer isolation. So, super important. Consumer meter tails. So these are the ones that are coming from the meter into here, and I can see that they're absolutely fine. Right, so pass to this. For PV or any other power generation systems, customer has nothing like this in this property. Earthing and bonding arrangements. So we've checked their size is good. We've checked continuity to the actual gas, security of fixings, and now we're just being asked about it. So sometimes one problem could relate into 3 or 4 failed regulations on the EICR. Presence and conditions of earth electrode, we don't have one. Provision of earthing and bonding labels, yes. Confirmation of earthing conductor size, yes. So this is the question. If you've got 25 millimeter tails, you have to have a 16 millimeter earth, and that's okay here. So is the bonding. Accessibility and condition of earthing conductor at MET, main earth terminal. This is that bad boy. Sometimes there is a separate one outside the fuse board, but we are just relating to this one here. Pass. Confirmation of main protective bonding conductor sizes, done. So you see the questions are very similar, but they are different questions. They mean different things. Condition and accessibility of main protective bonding conductor connections. So this is that little clamp that it was on the gas pipe. Accessibility and conditions of other bonding connections. These are not applicable because we only have gas.
A few moments later.
I've done a pull test on the cables just to see if they are properly terminated. Nothing is loose. I checked also the bus bars from the bottom, so I'm actually happy to answer pass to that question. Okay, final circuits. Let me crack on with this, so this is not too long video. The next test I'm gonna do is the installation resistance test on the whole board. I'm going to omit the RCD just to make sure I'm not testing this through the RCD. As you can see, neutrals and lives will be connected together using this R1, R2 link. Mega ohms resistance insulation, and we're going to use 250 volts. I'm pretty confident we've removed everything from the loads, but we'll double check. Both lives to earth, and we're going to start from this circuit first. Let's test. high in 300s. That's beautiful. Let's go to the next one. Nice. Next one. That's the actual cooker. Beautiful. Now we will swap over this to that side. If I find something lower than 100, then I will remove the neutrals, I will remove the earths, and I will do it individually, solely that one circuit, because obviously I want to definitely make sure what is the reading. But if I'm in hundreds, then that is just a confirmation that everything is fine. So the right hand side of the board, 100, 200s, and we're going into the... It's growing, yeah. So into 300s, nice. So now I know that my one cable is put into the earth sockets, earth pin, and when I do that, I get continuity. And if we to null the leads, so if I put it in the socket and then touching the metal enclosure, nothing. So it appears that there's no continuity. So there's two things we now need to verify. First one, is it connected to the earth properly as it should be? Or secondly, maybe it's double insulated, so it's a class 2 appliance and it doesn't rely on the earthing. But to check that, we need to get access to the connection behind, or maybe if we find a label from below, whether this is a double insulated appliance or not, by removing filters. And yeah, that's what we're looking for. Let me point it out to you. We're looking for this square within the square, so that's double insulation. That means the appliance does not rely on the means of earthing. Even the cable here, I'm not sure if you can see it, is flat, so it doesn't even have the earth inside. So double insulation. So getting a shock from a metal enclosure, I believe this was a static charge. So this is where the actual client might have carried the charge and it was just discharged onto that metal casing. Interesting, because it's not connected to earth. I will do a pat test on this just to double check if it's not leaking any current to the actual enclosure. So we will do that as well. It's been only an hour and a half. Only by now I'm actually getting into where I'm actually testing the installation. So all that time it was just getting to know the installation, going and checking around the house, doing all of the questionnaire. Just that alone is 90 minutes. That's what it took me to actually do this. And now filling the details and testing the circuits, this is now that moment. I cannot rush this, because if you're rushing, you make mistakes or you do not verify properly. So let's copy the details from the fuse board onto this and start testing. So now it's the time that we need to do end-to-end ring continuity testing. It took me 15 minutes to put the information in a certificate and pre-fill the table. So firstly, let's null the leads. It's 0.09. Here we go. So it remembers the resistance of the cables. I've loosened up the screws. I can see that someone has thought about it, and the spur from the 30 circuit breaker they've taken, they've actually put it separately on the neutral bar and separately on the earth bar. These two earths would correspond to these two lives. So let's just double check if that's how they did it. And we are testing the circuit number 2 for now for ring continuity, and that's R1 value. R1 is live, so end to end. And the value is 0.52. The next one is Rn, which is a neutral. And they should give us exactly the same value as lives. 0.543. Nice. Earth should be 1.67 times higher. So we would expect something of 0.7 maybe? 0.91. 90 actually. 0.52, pardon, 2 times 1.67. That's 0.86. So we're 0.90. Pretty good. That means maybe a little oxidation on the connection. That tells me the ring is really well. But that's not the end of it. We actually need to go around the whole ring and test it out. Live from this cable, I am connecting with the earth from that cable. Clipping them like that. You can use Wagos. I'm just demonstrating what I have right here. I'm using anything I've got around me. Now I basically created a big massive loop around the whole house, and the next value I need to go and check is the R1 plus R2, and that's what we are now going to verify, going around the house, around the sockets upstairs, and I need this adapter. And off we go. Testing. I'm not sure, this is maybe a 7th time I'm climbing this stairs.
Wait, baby! Go!
So 0.38. We should be expecting the same value across all the sockets. 3.2. It might be oxidized more. 3.3. Some of them might be really good and nice and clean, not oxidized. 3.2. 2.9. Nice. 3.9, good, and so on and so on, all of the sockets. Let's pick things up, nice, to those sockets. 0.30. Lights. That's a bit higher. 4.3. 4.4. 3.5. 6.1, that's the spur. 3.1. 0.29. 0.52 on live, 0.54 on the neutral, but nothing on the earth. Clicked somewhere downstairs on the ring circuit. The earth is non-continuous, and that is the problem. So we can't really verify R1, R2 for the ring. So is N and A for that one. So it failed. And N A for this one as well. It doesn't have it, which is not good. Not good. I can measure ZS. I can test the RCD. Well, there's no AFDD. But yeah, that's the problem here on that circuit, which would require further investigation in order to find out exactly where that issue is, find and put it together, fix it. This is one of the super important situations with the downlights. I recorded this recently on the previous EICR. On this occasion, everything is absolutely fine. So the last inspection was 2011. And that's how we used to be allowed to leave the connection under the risk assessment that is actually, well, it's not accessible because it's in the ceiling, it's downlight, it's not something that you maintain. You could even argue the point that you can just change the light bulb without removing one of these. But actually, the regulation states now nice and clearly that single insulated cables outside the enclosure, it's no. Sleeve, tape, everything. So they've done what they could at the time. But even just to give them some credit, how can you terminate both cables into that termination? You can't. You need a junction box of some sort beforehand. So this goes back in, and I'm sure there will be a million other houses in the UK exactly the same. This is an interesting one. Immersion heater. And I'm unable to actually open the cover because we have the pipe, the main pipe. Oh, Mr. Plumber, if you could have just used a little bit of your imagination and not put the pipe right in front of the isolation switch, it would be so much easier. But yeah, this looks like it's the boiler hot water system. So I think it's a system boiler which fills this up, and that's in turn returns the hot water and hot water for their clients. So unable to access that. Not really good. Well, I could perhaps maybe gain access to the actual heating element and do it that way. That is the three-way valve port. Yeah, that's another one. That's where the heating element is. The cable is suspiciously small. Okay, that's the bigger one now. Yeah, not the best way, Mr. Plumber. Yep. Mr. Plumber, you failed. At this point, we are finish testing the circuits, and I'm going back to the inspection of schedule, and no basic installation of a conductor visible outside the enclosure. C2, spotlights, fail. Adequately connected at the point of entry, enclosure lamps. C2, this is for the spotlights and for the light outside. Suitability of accessories for external influences. C2, the lamp outside is failing. The rest of it, I'm pretty happy, and well, no continuity of the ring circuits. Okay, I'll need to add this manually.